Hi, I'm Colin Walls, and I'm here again to talk about embedded software. And today I want to think about multicore. Embedded systems with multiple processors on them, multiple cores, are becoming almost the norm. The percentages vary depending on the look at the source, but at least a third of embedded systems have more than one processor, and they can have almost any number. It's worth looking at the options here from the software perspective. Now, from the hardware design point of view, there are two kinds of multicore. There's homogeneous multicore, where you have multiple processors of exactly the same architecture. Then there's heterogeneous multicore, which is where all the cores may be different in some way or another. May of course be a mixture here. Heterogeneous may have several identical cores and then some different cores as well. But those are broadly the two hardware architectures that are available. Now, from the software engineer's point of view, there are two ways we can make use of multicore. If you have a homogeneous multicore architecture, you can use symmetric multiprocessing, SMP. The idea here is you run a single instance of an operating system over all the cores in your system. That would have to be an appropriate version of the operating system. So the example I show here shows Nucleus SMP, which is an SMP version of the Nucleus RTOS running across multiple cores. This is the approach you use if you're simply using multiple cores to get more computing horsepower. This is what's done on desktop computers and even things like mobile phones are programmed in this fashion. So that's symmetric multiprocessing, SMP. The alternative is AMP, which is asymmetric multiprocessing. In this case, you'll run a different operating system, or possibly no operating system at all, on each and every processor. You'll need to put in communication between them and things like that. And you may choose to use the same operating system on some of the cores, but you may optimally choose a specific operating system on others. In the example I show here, we have Linux running on some cores, using Android on top of that, and we have Nucleus running on others. So in a system like this, we would use Nucleus for the real-time component and the Android component for the non-real-time. That's a typical way of implementing AMP. There are many other facets to multicore. There's the debugging issues, the programming issues, the code segmentation matters, multicore communication in an AMP system. There's lots of ways the processors can communicate with one another. All these other things can be looked at in more detail, and I'll come back to them another day. But for the moment, I hope that's a useful introduction to multicore from an embedded software point of view. And as I say, I'll come back to it again another day in more detail. So that's all for now. Until next time, bye for now.